Kia ora koutou, ko Dwayne tōku ingoa. I'll hand over to my colleague Mārama to start us with karakia.
Tēnā koutou, me karakia tātou. Whakataka te hau ki te uru, whakataka te hau ki te tonga, kia mā kina ki uta, kia mā taratara ki tai. Ka hiake ana te atākura, he tio, he huka, he hauhu, tihei Māori ora.
Kia ora. Kia ora. Well, welcome to today's session. Te Mārama ki ngā Whenua, using earthquake and earth science data for Māori GIS and mapping kaupapa. I'm joined today by Jonathan Hanson from Earth Sciences New Zealand, and he's the GeoNet Data Manager. What we'll do today is Jonathan's going to take us through some of the GeoNet sites, and then after that we'll have a look at how you can use and capture some of that data for your own mapping kaupapa, making your own mapping project. And then any pātai, any questions that you might have as well as we go. I'll be keeping an eye on the chat, and yeah, we'll either, if you've got pātai questions, we can have them as we go, or we can hold off to the end and then pause the recording or something and see how we go. Anything that you see today, we'll be sharing an easy to access story map with those links. But otherwise, yeah, kia ora, I'm going to hand over to Jonathan.
Cool. Thank you very much, Dwayne. Kia ora, everybody. Tēnā koutou katoa. Ko Pakeha te whakapaparanga mai. Ko Bahamas I Kanata te whenua tupu. Ko Ruapehu te mauna. So Ruapehu is the volcano that inspired me to be a volcanologist, so it's a really key part of my story. Ko Lyle Bay te moana. That's the moana that I live by, I swim in, I surf, I kayak in. Ko te whanganui atara te kaina. He GeoNet Data Manager, aho ki te whātuao, or Earth Sciences New Zealand. Ko Jonathan Hanson, tōku ingoa, and tēnā koutou katoa. Thank you guys very much for having me. It's a really great community, it sounds like you guys have, and honored to be here. A little bit more about my role. I also have kind of a few response roles in volcano monitoring, and then also I'm the scientist in charge for earthquake and tsunami. So if there's any kind of questions adjacent to that, happy to answer them. I'm based at Earth Sciences New Zealand, or we've just been christened with a taiao name, which is really awesome, so te whātuao. And I guess I'm a geologist in many of the classic ways. I like the outdoors, I like rocks, I like data and things about rocks, and happy to talk about that. So today I'm going to talk a little bit about GeoNet and some of its data offerings. But I also just want to make sure people are aware that what I'm going to talk about today is basically the tip of the iceberg of the kind of data that's available here at Te Whātuao. And yeah, as Dwayne mentioned, there's already been some links shared. We'll repeat those again. So if you want to follow along, go ahead, but also don't be shy about interrupting with any questions. So I think a good place to start is, what is GeoNet? To a lot of people, GeoNet is a website, the very website I've opened up here. It's an app. It is those things. But GeoNet is also kind of a complete network from sensors on the ground, with a big pipeline delivering data and products out the other side, all focused on kind of hazard monitoring or supporting research. And the website in front of you and the app that I mentioned, they're not just websites and apps, they're also kind of data portals. So within each is kind of a rabbit warren, potentially, of interesting things. So GeoNet is funded by MB, LINS, NHC, the Natural Hazards Commission, and NEMA, and then we're hosted at Earth Sciences New Zealand. There's a multi-peril focus to GeoNet, so you can kind of see that expressed in the tabs across the top. We're monitoring earthquakes, we're monitoring landslides, tsunamis, volcanoes. That's kind of our remit. When you get to the home page here that you can see in front of you, so one, you'll probably note these excellent LINS base maps that we use. Thank you very much, LINS. But also you can see kind of the latest reported shaking by people through our felt reports. So if you want to submit a felt report, you just click here. You can also do it on your app. We have English and taiao options, and would really encourage people to do that. It's really an awesome contribution from the people of New Zealand, and we appreciate it a lot. You can also see the volcanoes that are currently at unrest level above 0. So those are Whakaari White Island and Ruapehu right now. And you can also see some of the latest news stories that were made available. And if we scroll a little bit by peril, you can see there's a bunch of stuff under earthquakes, quite a bit under landslides. When you get to tsunamis, you can go to places like the Tsunami Gauge Network. And so here you can see the network of kind of coastal gauges that GeoNet operates around New Zealand. You can click on one. You can either get the raw data or the detided data. And you can take a look at what's happening at the coast, potentially if you pick one near you, then in your neighborhood. So what you can see here, there's no tsunami in this signal. This is just a tidal signal with some waves being recorded on top of it. And then what else is cool if you want to kind of build on top of that? So this page I went to is really great for exploring the tsunami data. But if you want to get a bit more involved, you can go to this link here, which takes you to our Tilda Data Discovery tool. And you can access the same data here. So we'll go to coastal, we'll go to water height, we'll select Castle Point. We'll just use one of the sensors. Last 30 days, no, yeah, we can look at the last 30 days. And so there's two cool things that have happened right now. One, you can get quite selective about the data you want to see. But two, we provide an API right here at the bottom. So it's really easy to embed that in any tools you might want to be building. Going back to the main page, we're lots of volcano data available here. You could check out our volcano cameras. These will give you kind of a live view of what's happening across the volcanoes in our motu. None of them are erupting right now, it looks like, which is good. That would distract me for the rest of this session. But that's another cool resource that's available. And then the last one, or not the last one, the next one we'll look at is that I think is interesting is the sensor map. So this is a map that shows all the sensors that GeoNet operates across the country, across the motu. And so if you want to see what data is being collected in your neighborhood, you can select, well, that's with all of them, which includes some in Scott Base. So I'll zoom back in to New Zealand. But let's say you're based in Mahia. This gives you a little window into what data is being collected kind of in your area. You can click on it and find out a bit more information. And through that kind of information, you can link it back to accessing it. So just to help people explore what's happening in their rohe or neighborhood. We'll now jump back to earthquakes a bit. Because I just wanted to talk a little bit more about what's available over here. So if you go to earthquakes and click earthquakes, what we can see now here is all of the weak or above earthquakes that have happened in New Zealand over the last little while. You can filter this to see moderate ones or stronger ones. There haven't been any severe ones in the last little while. That's great. That's the way we like it. And if you're looking at one of these stronger ones, so let's say we could pick this magnitude 4.6, oh, that's the 4.7, but they're both quite near each other, near Pongaroa. Click for a bit more information. You can see the felt reports that have been submitted by the community related to that event. So yeah, this is what people have submitted. Or you can also click this tab here and see the shaking that is kind of modeled or predicted for this event. So I'll zoom back in a little bit. And you can see the kind of MMI intensity here, which is just a shaking intensity scale we use. And so this is a great tool for when there's an earthquake in your area. If you want to know how strong the shaking has been, through that some likely or potential impacts, this is a great tool to use. If we scroll down a little bit, there's some really useful information here. There's links to the API for shaking layers, again, in case you want to build on top of that. There's a link here that I'll click on in a second to see a bit more detail. And I mentioned the MMI scale. If you want to understand what those numbers mean, you can click down here. But let's click through the shaking layers information. So I clicked a link related to a certain earthquake. So this is the earthquake ID here. So we've gone to information about that specific one. You could also go to recent quakes, and you can see all of the earthquakes that we've generated this shaking map for. The latest map is available if you click here in a PDF form. So this was an event kind of near Wanaka. Again, you can see there's kind of a shaking distribution. The colors are representing intensity of shaking. This one wasn't too strong, which is good. You can see these are the sensors that have picked up this earthquake, or the shaking for this earthquake. So they've helped us kind of model this shaking. And then down below, you can see the scale. So for the shaking, the potential expected damage. So this can be a nice resource too, but it's a bit static. So it's just a PDF. If we go back to this shaking layers page, you can click here and see past runs for this earthquake in case you want to see how this information evolves with time. For small events like this one, there isn't much changes in the shaking outputs with time, but for a big event, they can be quite substantial as we refine the solution and learn more about the event. But one of the coolest things, I think, for this audience is that you can click on this link here, and you can access this shaking information as a GIS layer. So I think Dwayne's knocked something together where he'll show you some of that information, or we'll look at some of that information plotted against things that help make it meaningful. And this is how you kind of can get there quite easily. So you'll see right now there's a bunch of different earthquakes across the top. They have this ID. You can either go to a specific earthquake that you're looking for, or you can come down and select something like the last 30 days, which will gather everything that has happened in the last 30 days together. So you can open this in a map viewer. Give it a second. And what you'll see here is the earthquake shaking intensity that we've been kind of recording or forecasting for New Zealand. So you see we have a little bit of a range around New Zealand that we're interested in. So we're capturing some of these bigger events in our neighborhood, in our global neighborhood. But you can also zoom in and find an earthquake that is happening in New Zealand, and this gives you a nice way of accessing that shaking intensity information. So again, this one wasn't very strong. I think it reached moderate levels. Yeah, that's right. So you can click, you can see some of the information about the intensity at the point where you're at, gives you a bit of a description, tells you what the event ID was, what the depth of the earthquake was, what the magnitude of the earthquake was, and a few bits of other information. So yeah, this can be really useful to overlay with different things, or just to give you some rapid context. No, sorry, don't click in things. Where am I going to go? I'm going to go up here.
This is looking great.
Thank you. So if you want to find out some other things you can find through GeoNet on GIS, you can just type GeoNet. Oh, I'm getting all the sites. I was trying to, maybe it's this one hidden under here. Anyway, if you should be able to, there we go. If you click this, you'll find the GeoNet, the GNS GeoNet group on ArcGIS Online. And if you click View Details, you can find all the different offerings, yeah, down here. You can find all the different offerings that are available through GeoNet and ArcGIS Online. I should mention too that a lot of our products are collaboratively made with different research programs. So for example, Shaking Layers is a collaboration with RSET. But yeah, you can click View All Content. And then you can find some other really cool things in here too. And the one I wanted to show you was the probability of a landslide based on recent earthquake activity. This one is another collaborative product with a research program. And we're going to open it up right now, but it's not going to show anything because there haven't been earthquakes kind of significant enough to generate a lot of landslide activity in the last little while. So again, this is good. This is kind of how we like it. But here's an example from Kaikoura. So I pulled this out of the archive to show you guys what a bigger earthquake could look like. So it's predicting or forecasting landslides in quite a wide range up here in the northern part of the South Island. You can see the likelihood, the probability. Here, kind of color-coded on the side. You can zoom in, you can overlay this across other resources you might have. So again, it can be a really powerful indicator of where landslides are likely to have occurred. They don't guarantee a landslide has occurred anywhere, and they don't guarantee a landslide hasn't occurred anywhere. That's one of the tricky bits about probability. But we can generate some pretty quick forecasts of where landslides are likely to have occurred. I'll just show you guys something else that I think is really interesting from a GIS access point, which is the New Zealand Active Faults kind of database that GNS used to run, now part of Earth Sciences. We haven't updated the branding. That'll happen in time. But what's really cool about this resource too is it shows all of the faults in New Zealand that we can map. So it doesn't show all the faults that exist in New Zealand. New Zealand has a lot of faults, but it shows the ones where we've been able to either see a surface rupture, so where that fault has displaced the ground, and so we can map its surface extent, or there's been enough earthquake activity that we can be confident about being able to map that fault. So you can go to the web map service, and you can open here the ArcGIS online map viewer, or other options, but that's the one we'll look at today. And again, you got to zoom in back on New Zealand. But what you can see here are the known faults around the Motu. That doesn't mean there aren't a lot more faults. I can't stress that enough. This is not the full extent of them. These are the ones that we can map. But it kind of really nicely illustrates how seismically active our country is. And yeah, it just gives a nice flavor for that. So this big one down here, I think we can all guess which one that is. That's the Alpine Fault. But you can see a lot of prominent faults that you'll know, or you can zoom in on your neighborhood again. If we pick Mahia again, and you can see we've been able to map some faults in the area, but there probably are a lot more in there. So that was kind of my quick spin around GeoNet data, touching on some earth science data, and giving you guys a bit of a feel for what's available at the GIS level. Are there any questions or anything anybody would like to hear anything more about?
There's, I've got a couple of questions for you. Question there, generic question there from Keith about prediction of earthquakes, and fault, sort of a statement there from Alex about the fault layer is entirely helpful when finding unusual elevation offsets in LiDAR. And I'm just wondering, Jonathan, if you'd mind if we ask our participants for one or two places of interest, and then perhaps we could zoom down, have a look at what data is available for that area, or so the partai is out there for everyone, first come, first served. If you're interested, and if you live near a fault or you have a fault line that you're interested in, put that place into the chat. There we go, Ruatoki North.
Sounds good. And Before we get there, though, I might talk about the prediction question that came in, because I think that's a great question. I mean, the short answer is we can't predict earthquake activity right now. So earthquake activity happens. Earthquakes happen on faults, often, deep below the surface. They're related to processes being driven by plate tectonics. So these are big, complex, quite awesome and impressive processes, if we're honest, but also very hard to understand fully enough to predict earthquakes. So right now, that's not where the science is at all. Maybe we'll get there one day. But what we can do is we can forecast earthquakes. So that means we can put a likelihood of the occurrence of a certain size of earthquake occurring over a certain time period. And we can do this on kind of the general scale. So we can look at New Zealand as a whole. There's programs that do this quite a lot. And then also after there's been a big earthquake, we can do this with a bit more precision. So what are the impacts of that big earthquake? What do they mean in terms of the likelihood of more earthquakes in that area? So we can produce things like forecasts that have a probability of shaking over a certain intensity. So that's on the MMI scale that I briefly touched on before, over the next year. So it gives you a timeline and a likelihood rather than a prediction. But we can do that across all kinds of timescales, and it's really interesting kind of work, and we're always getting better at it. So yeah, that's kind of the state of the art, not predictions, but we can forecast. So is there another question before we drive in an area, or?
Yeah, there is. I think we've got a few good options there for where we head to next. But just before we do, a general question from Cameron about can we map underground geography? And just to throw in there, my first thought was we kind of can, but it's how we visualize it, I think, is the challenge. But what are your thoughts on mapping underground?
Yeah, no, I think you've nailed it fairly well. So the way we can kind of, I guess, map underground is we can do a lot of detailed work on the surface. Then we can understand what is happening at the surface, and we can use that to extrapolate down underground. So that's probably one of the most powerful tools we have in that regard. That's the kind of classic geological approach. If you imagine older rich gentlemen of a certain period wandering around the world looking at the rocks and making interpretations of what's happening underneath. We do the same thing, but obviously a lot more precise, and we're a lot better at it now. The other way you can map the underground is you can send certain, I guess, pulses of energy into the ground. They will reflect back off surfaces in the ground. And then by analyzing, say, the timing or the intensity of that reflection, you can start to understand where there's surfaces underground. So it gives you a limited view into what's happening below the surface. That's especially prominent in exploration geology. So if you imagine you're looking for oil or something like that, that's one of the biggest tools they use. And that's, to give it its scientific name, we call that seismic tomography. So it's understanding the seismic waves and how they pass through the earth to give us a picture of the underground. And then Dwayne's point is really good too, which is it's how you visualize it is a large part of the problem. So when we do these studies to help us map the underground, you often get kind of lines rather than a 3D image. So you kind of have to stitch those together to create your map of the underground. Just thinking about that too, the other things we can use to map the underground is we can see where earthquakes are occurring. Earthquakes will be occurring on faults, so that helps us map where those faults are. Where those faults are is usually related to some kind of a geological reason. So it could be the edge of a magma chamber. It could be where two plates are colliding. And another thing we can use to map the underground is we have these really sensitive gravity meters. And so they measure really tiny variations in the Earth's gravity that we would never notice. And you can use those to infer something about the density of the rocks below you. So those methods, plus probably a few I'm forgetting, can all be combined together to give you some images of the underground. But yeah, their accuracy will vary based on what's happening and how deeply people have looked at it. Sorry, that might have been a bit too much of an answer there, but
that's good. We will, after we've had a bit of a data explore with Jonathan, what we will do is show you how to add some of these data sets into your own maps and to access them for yourself. So, Jonathan, how do you feel about navigating down to Ruatoki North, which is near to Whakatane?
Yep.
Makatu kind of area,
yeah,
and seeing what kind of fault lines and recent earthquakes, or if we find a couple of, if you could find a couple of data points to just have a look into. Yeah, if you come to Whakatane and then zoom in a bit more.
Yep.
A bit more, you can see Tani Atua there.
Oh, no, I've rotated it.
Okay.
Yeah, Tani Atua.
Tani Atua, and a little bit inland.
Okay, somewhere around here.
Yep, that kind of general area, I think, yeah.
Yeah, cool. Maybe I'll zoom out just to make sure I stay referenced right, if that's okay.
Yep.
Yeah.
Or just hit refresh if you want to straighten the map up again, if
yeah,
that's making it challenging. Oops, never mind.
Nah, it's all good. It's all good.
Trick it this time.
Yeah, exactly.
Kind of near to, I thought that was a really good example. It's near to
there we go.
the big earthquake when I was a kid in high school near Edgecumbe.
Yeah. Yeah, so there's a few cool things you can probably do. So I found it eventually. You can change the filter up here to see all. Oh, it's reset itself. But anyway, this will show you where all the earthquakes we've recorded in the last little while have occurred, not just the ones of a certain size. I need to zoom back in again. Oh no, I've lost it. Sorry.
Oh, so
there it is. Okay, cool. So there hasn't been much activity recently, which is probably pretty good. But what you can then do that I think will help a bit is you can go here to the quake search. You can set a range of different time frames that you're looking for. You can zoom in on the area of interest. Oh, it looks like we don't get quite as much resolution on this map. So yeah, you can set your time frame. We can look at the last year. Make sure you set it high enough to get all the events that have happened. And so now you can see the earthquakes that have occurred in the last year in the area. You can also set a kind of custom date range. So we could see something like the last roughly 20 years. And you can see there's now 700. Okay, it's looking pretty busy now. Now 700 earthquakes have come back. They're kind of color-coded based on their depth. And then the size of the circle reflects how big the event was. And then if we want to go back and try to find the Edgecumbe event, I don't remember off the top of my head when it was.
Late. It doesn't matter. It's any is fine. It's more. It was just like late 80s, but
yeah, it's totally fine. So we can set a date range that will cover it. And then what I've just done there is to not get quite so many events, I've put in a minimum magnitude. So that will help big earthquakes kind of appear. So yeah, these are the earthquakes above magnitude 5 that have occurred since 1980. I suspect, no, that's not it. Where's the Edgecumbe event? Over here? No, it's deep.
It's good.
Anyway, I might have the date
you
range
could see
wrong.
You will have seen photographs of the effect of the fault lines in the fields in the landscape.
But what's worth noting about older events like the Edgecumbe event is some of those are before GeoNet or digital seismometers. So we haven't captured very small events from those time periods. And then we're not able to refine the solutions for those events as well too. So GeoNet got founded in 2001. With that, there was a big expansion of New Zealand's seismic monitoring capability. But if you go before that, sometimes you're in more analog eras. And if you go back quite far, then we're based on kind of oral reports. So their catalog will go back to, I think, 1700. But the events get pretty sparse and they get a bit more uncertain. So bear that in mind when you're delving into the catalog. And maybe the other thing we could look at just before we move on is what sensors are local. And so we can zoom back in. If I remember right, yeah, we're over here. So there aren't any sensors in Ruatoki North. The closest sensors are kind of up here, getting towards the coast. But you can see there's a GNSS, so a positioning-based site, so measuring really precise land movements. There's another one over here. And then your closest seismic stuff is there's a strong motion sensor, so they're really good at sensing strong shaking from bigger earthquakes. And there's a camera here, which is what I was trying to find. So that camera is actually pointing out at Whakaari. So this is one of the web cameras that we use in volcano monitoring that's pointing out towards Whakaari to help us understand the activity that's going on out there. Anything else I should delve into locally? I could look at the fault map if people would like.
Yeah, I think it'd be great just to see what the fault map represents.
Yeah.
Just to click and have a look at what are the attributes on there and how can it, you know, obviously they don't exist at the surface until there is a big event, but what are they telling us? How deep are they? And what's the significance of living on the red line, for example?
Yeah, well, I'll handle maybe that question first, because I think the significance of living on the red line is almost less important than noting the significance of everybody's living near a red line. So New Zealand is a great place, but the tectonic activity that has made it such a beautiful place also means we have a high likelihood of earthquakes occurring in our country. And I think the biggest lesson is that everybody across New Zealand should be prepared for what they would do in a significant earthquake. So there's things like drop, cover, and hold that I think everybody's got nicely ingrained. If you live near the coast, you probably want to have also learnt long or strong, get gone, which means if an earthquake is long, so maybe the shaking lasts, say, something like a minute, or if it's strong, so if you have trouble standing up during the earthquake, that you should self-evacuate to high ground basically immediately. So, for example, I live in Lyle Bay. It's a tsunami-prone area, let's say. And I have a grab bag full of a few things like my passport, a sweater, a bottle of water, ready to go. And if I felt an earthquake that, you know, I had trouble standing in or lasted for a certain duration, I'd be heading up the hill and not waiting for official advice, even though I'm part of the group that will be providing you with some of that scientific advice. We try to do it as quickly as possible, but the reality is the earthquake could have happened right underneath you. The tsunami could have been generated very close offshore, and there simply isn't time to get those warnings through. So long or strong, get gone is probably the most important sentence somebody in New Zealand can memorize, I would say. Was that more or less your question, Dwayne, or did I digress a little bit? So you wanted to know what information we can see on this map. So on the GIS layer, I think there is more information. I thought you could click and see it. But let's go back to the GNS active faults. If you go to the interactive map here, So it's another.
Could you have a look over on the other side, perhaps, if there's any, what's near a question there from Angeline about relating to faults, if there are any around the Whangaroa Raglan area on the other side there, sort of west of Hamilton, but it doesn't look like there's much there.
Not much mapped there, and there isn't.
Yeah.
It isn't.
Okay.
It is one of the seismically less active parts of the country. But yeah, just reiterating what I said before, all of the country needs to be prepared. But yeah, just wanted to follow up on what information you can learn about the faults. So this is the Whakatane fault. If it has a name, they don't all have names. There's some scientific information about what kind of movement occurs on the fault. There's recurrence intervals if we have enough data to understand them. So that means roughly how frequently we see significant events on this fault. And there's things like slip rate, which is how much movement there is on this fault. What the potential single event displacement is, so what the biggest potential earthquake you could have on this fault is. As you can see here, we don't know for this fault. And when the last significant event was. So there's quite a lot of, I think, very interesting information, but of course I should let you be the judge of that. But yeah, if we go over here towards Raglan, yeah, there isn't much mapped, but there will be faults that I don't want to say we don't know about, because we know they're there, but we don't have enough information to confidently draw a line that indicates where they are, if that makes sense.
Does. There's a question here from Keith, just in relation to, do the fault lines differentiate between vertical and horizontal movement? And also relating, Keith, based in Taranaki area, obviously there's a lot of exploration activity that's happened around that area, which I know we can get from MB. Name of the subpart escapes me just now, but I'm sure someone will know it. But they have a lot of data there that's available as well. But not too many faults there, but it look well drawn.
Yeah, exactly. So these are will be the tectonic faults, right? So the geological faults. If an earthquake is induced because of something people are doing, it may not be occurring on a fault at all, right? So that can be related to some of the exploration work going on. In terms of what GeoNet will pick up, we'll pick up earthquakes of a certain size, no matter what has generated them. So we pick up both kind of tectonic earthquakes, which is related to the faults moving around or the plates moving around. We will also pick up anything that's man-made, or in the Taranaki case, of course, we might pick up things that are related to magma movement. So just to be clear, we're not currently observing anything related to magma movement at Taranaki. So what we're seeing here is all tectonic in origin, we think. But there could be some man-driven stuff in there too. So you can still monitor, we're still collecting, we're still locating those events regardless of their source.
And follow-up question just on, particularly perhaps in this area with fracking, is there any impact that you're aware of fracking and agitating fault lines in the areas so far? Whether that's a bit sensitive or not, but yeah, feel free to give it a crack if you want.
It probably is a bit sensitive, but I'm happy to be honest about what I know, which isn't very much, right? I'm not too close to trying to study fracking in the area. Fracking will be having an impact in terms of earthquakes generated. I mean, that's literally what it does, is it creates cracks. Cracks generate earthquakes, but they will be most likely too small to be felt. But they can potentially get into the felt range. I know this is something that happens up in the Topo area where they're doing some geothermal work. So yeah, fracking by definition is causing earthquakes. Usually they're too small to be felt. They can be bigger, but that's as far as I can really comment off the top of my head without looking into it a bit more in that area.
Great. Thank you. That's
Not
good.
a problem.
Just checking, just seeing if we've, I think we've covered most questions there. Maybe could we have a look at the Hikurangi fault lines? So I know that's a
Sure. So I think
big
the
area
best,
of interest.
yeah, the best way to look at the Hikurangi fault line is probably to just find any, map of New Zealand, especially one that has some bathymetry on it. So the Hikurangi fault line is coming just offshore, or that's where it is at the surface. It also descends below the North Island. So the Hikurangi subduction zone is a huge network of faults that stretches roughly from down here and then up into the Kermadec kind of area, where it's still all one system, one plate boundary, but we start to refer to it as the Tonga Kermadec subduction zone. But that's more of a geologist definition change than it probably is a real change. So there's a really big subduction zone and associated faults stretching all the way along here, and that extends up into the Tonga region. The same plate interface then comes across New Zealand, so it becomes the Alpine Fault. And then it also extends below here. So there's this contact between plates that runs along here. And what's really interesting is you have subduction on this subduction zone of the Pacific plate under the Australian plate. And then south of New Zealand, that's actually reversed, and the Australian plate is going under the Pacific plate. And then in the middle, where you're getting a transition between those two subduction zones, the plates are sliding next to each other rather than one going under the other. And that's our Alpine fault system. And then the associated faults in Fiordland and up into Marlborough. So sorry, that was probably a different answer to the one that was expected. But I think the other thing to mention about the Hikurangi is if we do have a big earthquake on the Hikurangi, and there is that potential, there would be a significant tsunami risk, especially to the east coast of the North Island, but more accurately, probably to all of New Zealand. So if that big event does occur, that's one we'll have to hope our preparedness is ready for.
And question for you, just thinking, moving on to a bit of how do you get your hands on the data, which is always something I'm into.
Yeah.
One thing I haven't come across yet is how to access the point locations. I've got some that I've cooked up earlier, but it's just a subset. I'm wondering, could you just show us if there is a way to access or export the point data set for earthquakes?
Definitely. So the easiest way to do it is you go to Quake Search. You can put your search in whatever it looks like, and then you can either build show on map or you can build a query. And then you can output it as a GeoJSON, CSV, or KML, or different things. So that's probably the easiest way to do it. For events above a certain size, those that generate something in shaking layers, there's a GIS layer that will have the last 30 days events.
Yep.
And then just on the topic of data, I probably haven't stressed enough that everything GeoNet collects is open. So it's something I'm really proud of. I love that aspect about my work. Everything we collect is available for people to build on. And yeah, we hope it's a great resource for New Zealanders.
Thanks, Jonathan. So I'm just thinking, there's a question there from Shane, actually, just before we do move on, we'll do a bit of a map hikoi. Is there a full API menu somewhere that you're aware of?
Yes, full is a big word, but there is an extensive API that serves up GeoNet's data here. So it's not always the easiest to engage with, and we're always happy to hear some feedback on where we could improve it. But yeah, all of GeoNet's data delivery is backed up by an API. And for users who want to get into that kind of thing, would really encourage you to have a go, send us some questions if you're having any trouble. And it's an awesome way to get into GeoNet data.
Looks like you've made Shane very happy. So
excellent.
Geek out for the rest of the afternoon.
Sounds good. Enjoy, Shane.
Now, for the rest of us, I have got a little map that I've been cooking up while you were sharing with us some of that. I had something earlier, but for some reason it's not working, but doesn't matter. Do you mind if I share the screen for a couple of minutes, and I've put a link on the chat to an ArcGIS online map. And what I would like, Jonathan, is if you give me a hand once I've shown the folks what's here, so we can go and add some of those data sets from ArcGIS Online.
Perfect. Let's give it a go.
Does that make sense? So I'll just find the share screen button. Here we go. So if anybody wants to follow along, that link is in the chat. And is that all sharing now? I think. Can you see the map?
Yeah, I can see it.
Fabulous. Okay, so what I've done is I created this just today, and I went in here and I went press save, and I went share, and I copied that link and I put it into the chat for you. And I cheekily called this my Turu map, which means having a bit of a play. So this is in ArcGIS Online. You've seen Jonathan's demonstrated some of the views. This is just using a free account, so you can all do this. So what I've done is, if we have a look and let's pick a spot. Random spot picker. Here we go. I will stay near. How about come down near Rotoki again, somewhere in this area. So what I've done is I've added a couple of layers. I've added Marae of Aotearoa. So this is based on TPK. So this is a really useful layer. So you can see there. I've also added Māori land blocks, which you can turn on and off. They're a little bit hard to see because I was making this quite quickly, but you can click on them and see which land block that is. Turn those off again. And I also found, before we get into the good stuff, I found a layer from Eagle, who have rehosted some of the GeoNet data. I'll just turn off those Marae here. And there are some volcano cams here, so we can actually just zoom down and click on those and see a photo. Kia ora. And I've added the faults database. So that's the fault lines in there. And when I click on one, I can get those attributes. So the Whakatane fault, Ruatahuna segment, slip type, dextral. What's dextral mean, Jonathan? Do you know?
So dextral is, I guess, it's the motion of the fault on that plane, fault plane. So dextral literally means kind of to the right. And its sister is sinistral, which means to the left. But beyond that, it's a bit more complicated because you have to use a standard way of looking at a fault to know which way is right and left. But
and this is a normal slip type.
So normal, there's, again, different kinds of fault movement. And normal is when you have movement on a fault that goes kind of like this. So the sides of the fault kind of pull apart. And the sister of that is reverse, which is when they kind of go past each other. So again, there's a little bit of fault geometry at play there too.
Now, that question I had about viewing the point data. So I found here a layer that I think the GIS and Schools team had captured, which is 2010 to 2020. And when you turn it on, you get this.
You're going to get an awful lot.
Awesome spaghetti, which is kind of seems cool, and they thought, okay, what am I going to do with this? What I'm going to do is just make it so I can see it a bit more, and we're going to zoom out. But this is 10 years worth, and I've shaded it by magnitude. And maybe, Jonathan, could you remind us how magnitude works? Like if it's a 5 compared to a 6 or a 7?
Yeah, I'll try to do it in a way that isn't too complicated. But the other thing I thought is worth mentioning that I should have mentioned before is we locate over 20,000 earthquakes every year. So when you do a 10-year plot like that, you're going to get 250,000 earthquakes. And there's even more that are happening. They're just too small for us to be locating with our current system. So magnitudes, I think the most important thing to understand about them is that they're basically exponential in level. So a 6 isn't a little bit more than a 5, it's a lot more than a 5, and so on and so forth. So you can have this range from earthquakes that are at the kind of magnitude 1 level. You might not even feel that if you're right next to it, to things up at a magnitude 8 or 9 level, and those will be felt for thousands of kilometers potentially. Do you want more information than that? Because strictly speaking, a magnitude is related to how much movement occurs on a fault. So you get small amounts of movement at low magnitudes, and you get really big, potentially hundreds of kilometers of movement on a big one. So
let's have a look at adding some GeoNet data, because what I'm really keen to know is question I had for you, having a look at some of the data. So we've got the last 30 days layer here. We've got shaking layers, peak ground, more science.
Yeah, exactly.
More science.
So I think that's a great explanation of it. The top two are more or less the two I think that are most of use. So one of them is the MMI, which is the shaking intensity over the last 30 days. And the other one is the epicenters of earthquakes in the last 30 days. So where those earthquakes occurred.
Look at that. It's the same data as that the map you shared. There we go.
Yeah, that's awesome.
Close to home. So that I'm really keen on this concept, because this means I don't have to maintain the data. I don't have to download it. I don't have to do anything with it. It's just there, and it's always. And I think these are the last 30 days. So days at the 31st day is going to be falling off because it's not so interesting, perhaps. But
exactly. It's a way of decluttering the map, right? And also making sure that when there is an event that has had impacts, it stands out and is easy to find. And
so if I press save just now that I've added those 2 extra layers, once that is saved, if you're viewing this link from the chat, just press the refresh button up here and it will load in those new layers. But I just wanted to share that kind of that very basic thing. If you go to arcgis.com, create a sign-in. I use my Google. That link that's on the chat. And remember, once we finish this kōrero, that chat's going to disappear. So if you want to copy it and paste it into an email to yourself or a notepad, and this map will just sit there permanently available, but you'll be able to, you can always go back to the GeoNet site and extract out data depending on what your need is, what you're wanting to try and achieve there as well. Let me just check back through some of the questions here. Aroha mai if we miss any of the questions. Whānau. Janet, kia ora. So matawhenua.com is an easy link to come to that, and I'll add that map that I just made into that link as well for everybody. Question there about, Jonathan, are you aware of like Māori participation in some of the governance or the operationalization of the data? Have you come across, I'm sure there is some, but what can you share with us about that?
I'll be totally honest, which is I would love to see more. engagement on the governance of GeoNet's data from a Māori perspective. So there are several, or at least one prominent cross CRIs, which is what GNS used to be. Now Earth Science New Zealand, I assume, is part of it, but there's a cross CRI working group on Māori data governance that GeoNet is engaged with. But I think there are some very interesting conversations to have down that path, and personally, I'd really love to have them. So we kind of see ourselves as guardians of a taonga, right? This is a treasure of a data set that we see ourselves as the stewards of on behalf of the people of New Zealand, right? So there's really interesting discussions, I think, of what that means in terms of Māori data governance and ownership and all that kind of stuff. So not enough. I'd like to have more, and I would welcome that.
Kia ora. Thanks, Jonathan.